of imaginary? Hannah. Awesome. So see a negative, take that I out. Negative inside the square root. Okay? Now, you're left with the square root of 500. What are two factors of 500? Everett. 105. What's the square root of 100? 10. So I have 10I root 5 as your final answer. Okay? See a negative, I comes out. Now for number 2, we have 3/8 on the outside, negative inside. What comes out? Yeah. An I. And then what are two factors of 80? Yeah. Okay, good. 16 times 5. So the square root of 16. Good. All right. Now, can we reduce this? Because if we do multiply, it's 12 over 8I root 5. Okay. What can that reduce to? Liam? 4 okay. 3/2. Still like my fractions. 3/2 I root 5. Okay, you want to reduce that fraction when you can. All right. Now looking at 3. I is already on the outside. But what else is going to happen? And I is going to come out. So we have I, take out another I, then we have 99. Okay. I times I is what? Okay, we'll get to that in 1 second. What are two factors of 99? 9 and 11. What's the square root of 9? Now, should we have I squared anywhere? No. What does I squared equal? -1. Good. -3. 11. Awesome. You guys. Yeah, Rory. I squared automatically is -1. Yep, no matter what. Okay. Now let's look at number 4. Okay, we have -5I already on the outside. What comes out first? Yeah. Another I, good. We have 24. So we have -5I squared. What are two factors of 24? Emily? 4 and 6. We have 2 root 6. So now, -10, what does I squared equal? -1. That was your final answer. Okay. Any questions on simplifying negative radicals? Okay, so those of you that completed Delta Math, you did an awesome job. Okay, there were a lot of great scores. It had a little bit of everything in terms of simplifying radicals. Then it had some negative ones in there. So it was, good practice to see where you guys are in terms of simplifying. Okay, today we're going to extend our knowledge with complex numbers and get into operations. Okay, so if you have your notes out and turn to page 12, we have this guy here. Okay, so anytime we are doing any sort of operations, add, subtract, multiply, and eventually divide, we have to remember our final answer has to be in A plus BI or A minus BI. The reason is A is your real number, B is your imaginary, okay? So it's always your real number plus or minus whatever your imaginary is, okay? That's called standard form with imaginary numbers, okay? So when we're adding and subtracting, all you're doing is combining like terms. That's all you're doing. I is acting like a variable. So, for example, and they always put parentheses around it because it's always an expression, okay? So, for this, since we're adding, I could drop the parentheses to make it 1. And now I'm combining like terms, okay? I don't have another whole number, so -6. What's 4i plus I? 5i. And look how I wrote it. It's your real number plus your imaginary, okay? Real number plus your imaginary. Okay. Now if I look at B, we are subtracting. What has to happen in this case? We have 7 minus 6i minus 3 minus 6i. Yeah. Not cross multiply. I think you're thinking of another. What would you do in this case? Huh? You have to do something before that. You're on the right track. You're there. Need a little help? Liam? You would distribute the negative. Okay? So we're going to carry down 7 minus 6i, but we want to distribute that negative sign to both. So we have -3 plus 6i. The reason we want to distribute is because you're subtracting the whole expression there, the whole binomial. So now we're going to combine like terms. 7 minus 3. Great. 4. -6i plus 6i. What happens there? It cancels out. But I'm just going to put a placeholder in and put 0i. So you see, you don't have to do that. It's just showing you that the imaginary solutions cancel out. Okay? God bless you. Now looking at C, what do you have to do first? Everett. You also distribute. Good. So you have 10 minus 6 minus 7i plus 4i. What is your final answer? Emily? 4 minus 3i. Excellent. All right, you guys, try D, E, and F. Okay. All right, you guys, D. What do I have for D? Luz? Good. 13 plus 5i. Excellent. How about E? Mia? Good. 5 plus 5i. Excellent. How about F? Liam, go ahead. Awesome. Good. 23 plus 12i. How many of you did get that? Good. Okay. Any questions with adding and subtracting? Yeah, Everett? Yeah. They tend to, because you have expressions, that's why there's parentheses, but you really don't have to distribute the positive sign at all because all the signs stay the same. Okay? So then, yeah. So you have 16 plus 3i. Let's just check your signs, okay? Negative times negative, you get positive 7, and then positive 9i. Okay, just be careful with that. All right, so now when we multiply, we are distributing, or FOIL, okay? So what do you think is going to show up here? Let's see. 4i times -6 is what? Yeah, Mia. negative 24i. Then I have 4i times I, which is 4i squared. But what do we know about I squared? It's equal to negative 1. So I have negative 24i. It's 4 times negative 1. Okay, so right now I have negative 24i minus 4. However, is that in standard form? No, so we have to just switch it. And all you're doing is moving things around. You're not changing any of the signs. Okay, so negative 24i minus 4 is just going to become negative 4 minus 24i because you have to write it in standard form. Okay, all we're doing is rearranging. Now, multiplying, if you want to put a little reminder for yourself, you should not have I squared anywhere in your final answer. Okay, I squared should not be anywhere. If you see I squared, automatically change it to negative 1. Okay, so now we look at B. Okay, we have two binomials here, so we have to use FOIL. Okay, or you're distributing the 9 all the way through and then the negative 2i all the way through. So 9 times negative 4 is what? And you guys could call out for this. 9 times negative 4? Negative 36, thank you. 9 times 7i? 63i, thank you. Negative 2i times negative 4? Good. Negative 2i plus 7i. I mean times negative 7i, sorry. Good, negative 14i squared. Okay. So once you distribute, you have a bunch of stuff going on. Okay. We have the negative 36. Can I combine 63i plus 8i? Because they're like terms. What do I get? 71i. Then, what does I squared equal? Negative 1. So, I have negative 36 plus 71i plus 14. Am I done? No, not yet, right? What's the last thing you have to do? Hannah? Yep. Right, so we want to combine negative 36 plus 14. What do we get? Negative 22 plus 71i. And that's in standard form. Okay? All right. I want you guys to try C and D. Go ahead. C and D. All right, you guys, for C, what did we get? Hannah? Excellent. How many of you did get that? Good. 26 plus 2i. Any questions about that? No? Okay. How about D? What did we get? Yeah? Just 59, because what happened to our 6s, right? They canceled out. So if you had 0 plus 15i or just 15i, either one is acceptable. 0 doesn't really matter. Okay? Now if you look at E and F, we have 3 minus 2 squared. Okay? 3 minus 2 squared. So how many do you have of them? Where you see 3 minus 2 squared, 2i squared. Yep. You have 2 of them, right? So what I see a lot is we square the 3 and the 2i. That's incorrect. Okay? So we want to expand it out. 3 minus 2i times 3 minus 2i. And it's back to what we were doing. Okay? So go ahead and multiply and see what you end up getting for this one. Okay, what do we end up getting for E? Everett, go ahead. Excellent. 5 minus 12i. How many of you got that? Okay, let's go through it. 3 times 3. 9. 3 times negative 2i. Good. Negative 2i times 3. Good. Negative 2i times negative 2i. Positive 4i squared. So we have 9. We add these things, we combine like terms, so negative 12i. This becomes negative 4, and then we combine like terms. Okay? Calculator. Okay, so you end up with, hold on 1 second. There you go. Okay, 5 minus 12i. Okay, so we did so far, all together, we simplified regular radicals. We simplified negatives inside radicals. We added, we subtracted, we multiplied. Next, divide. Okay, turn the page. Now, what did we see at the end of our regular radicals for division? What did you have to multiply by? Yeah. The denominator. What about the denominator? Yeah. Right. So the conjugate, right? That's the same thing with complex numbers, okay? You cannot have an I in the denominator, okay? So if you look at A, we have 9 plus 12i over 3i, right? That's like saying 3 times the square root of 2, let's just say, right? And we have to rationalize by multiplying top and bottom by root 2. But in this case, we're multiplying by the conjugate, which is just I. Okay, for this one, when you just have 3i, 4i, 8i, you're just multiplying by I. Okay, multiplying by I, top and bottom. Okay, so now I have I times 9 plus 12i. I'm just writing it as one fraction. Okay, what do I have to do with the numerator? Yep. We have to distribute. Okay, we have to distribute, so we have 9i plus 12i squared. Now our denominator right now is 3i times I, which gives us what? Okay, now we see I squared there. What does I squared equal? Hannah? Negative 1. So 12 times negative 1 gives us what? Negative 12. So this becomes negative 12. So we have 9i minus 12, which I'm going to rewrite as negative 12 plus 9i. Then we have 3i squared. I squared is negative 1. So this becomes negative 3. Okay? So this obviously can be taken one step further. What do you guys notice? Yeah, Anthony. And what else? And 9. So that's a key point. Your denominator, in order to simplify, your denominator can only be simplified if 12 and 9, or these two numbers, can be divisible by it. Okay? So, what's negative 12 divided by negative 3? 4. 9i divided by negative 3? Negative 3i. And that is your final answer. Okay? Try C. Try C. These two parts here. Okay. So now, we have something that's very similar to the last problem of our simplifying radicals, okay, with dividing. We have 1 minus 4i in the denominator. What do you think we have to do to get rid of that? I said it before. Came up before. Yeah. The conjugate. So we have to multiply top and bottom by 1 plus 4i. Okay? We have to multiply top and bottom by 1 plus 4i. Okay? So again, this is the conjugate. Or the only thing you're multiplying by, the sign changes to a plus. Okay? Yeah, Hannah? Because we can't have I in the denominator. So let's go through this so you could see how it cancels out. Okay? So the numerator is 2 plus 3i, 1 plus 4i, 1 minus 4i, 1 plus 4i. Okay, so this is what it's like on one fraction. You guys have just went through multiplying. So go ahead and multiply the numerator. I'll do the same thing up here. Then do the same thing for the denominator, multiply. Okay? So we have all right, so I did different colors up here for you guys to see. The numerator, you should have gotten 2 plus 8i plus 3i plus 12i squared, right? Okay, that simplifies to 2 plus 11i minus 12, correct? Are we all okay? Yeah, okay. Then when you combine like terms, it's negative 10 plus 11i. We're good. Now the denominator, this is what you get. 1 plus 4i minus 4i minus 16i squared. Yes. hmm Because it's a negative and positive. So what do you notice that happens to 4i and negative 4i? They cancel. So that's why we multiply by the conjugate. Okay, because we want those i's to disappear. Okay, so we end up with 1 plus 16, because negative 16, we get that from negative 4i times 4i, which is negative 16i squared. Negative 16 times negative 1 is positive 16. And that's how we get 17. Okay, we see that? You okay? Okay. So with these, when you're multiplying by the conjugate, you want to take your time. Okay, you want to take your time because those little pieces can get lost in translation. Yeah, Luce. Yes. Nope. So I'm glad you brought that up to move us forward. So negative 10 minus 3i, the conjugate is just negative 10 plus 3i. So I want you guys to try this one on your own. Negative 10 plus 3i. So Lucy brought up a good point that The only sign that changed is the one in the middle, okay? The negative 10 stayed the same for both, just you change it to positive. Yeah. Go ahead, Roy. For the first one, this would be the same as, and then that's a great question. If we go back to radicals, right? We had, say, like 3 over root 2, right? This is the same as if I had 3 over I, where you're just multiplying by or rationalizing the denominator, okay? When you have an expression, square root of 5 plus 1, you're multiplying square root of 5 minus 1, top and bottom, right? Same thing applies with the i's. If I had 3 plus I, I'm multiplying by that conjugate. So when you have an expression meaning adding and subtracting, okay, that's where you multiply by the conjugate, okay? Try D, you guys. Okay. All right, guys, how many of you did get 36 plus 11i over 109? Good. That's good. Good. Any questions about D? Yeah, Kennedy. 30. Do you have 30 here? There you go. There you go. Okay, so again, easy little mistake to fix, right? And I'm glad you asked that because those little things do happen, okay? So it's better to correct them now and understand them before moving forward, okay? You guys have any questions? All right, the last thing is now we could solve by taking square roots because we know what negative radicals simplify to, okay? So if you look at A, how do I solve that? Everett. Good. So when you take the square root of both sides and we're solving, what do we have to include? Square root, solving. Square root, solving. Plus or minus. So x equals plus or minus. You see a negative, I comes out. What's the square root of 49? 7. Okay. So here, yeah, Hannah. Sure. So anytime you take the square root of either side. So here you might want to write yourself a note, all of you. Solve x by taking the square root. You must include plus or minus. Only when you're solving by literally taking the square root of either side. Okay? So when you're solving, you must include the plus or minus. Okay? So in B, what do you have to do first? Yeah, Everett. If you're taking the square root of both sides, so a variable, yeah. Okay, so like you wouldn't do plus or minus if it was like square root of just that? No. That you would just keep as 7i by evaluating. That's a great question. So it's only when you are solving. Square root, literally on both sides of the equal sign. Okay? So B, what would you have to do first? Hannah. That's a great guess. Good job. Okay. 2x squared equals, when we subtract 11, what do we get? Negative 37 minus 11. Good, good, good. Okay. Then what do you have to do, Everett? Thank you for saying that. Divide both sides by 2. Okay. So we have x squared equals what? Negative 24. Okay. Now what? Everett. You're correct by plus or minus 2i, but not root 5. Emily? Root 6. Okay, you were there. You were so there. Take the square root of both sides, plus or minus. See a negative? the I automatically comes out, and now we could simplify 24. So it's x equals plus or minus 2I root 6. Okay, guys, today was absolutely awesome. Great participation, awesome questions. This is what I love. You could see my change, right? I'm like ready to go. Okay? Maybe because there's a day off tomorrow. I don't know, but we're ready to go. All right, so we're going to do some practice. Okay? This is just in-class practice. I will tell you your homework in a little bit. I want you to try these whatever time we could get through. Start going through 1 through 14, the evens. Okay? So 2 through 14, I should say. Evens. This is in-class practice. We should have a few minutes to go through some of them, but I will put all the answers on Google Classroom as well. Okay? I'll tell you your homework in a little bit.